I'm live, watching myself live in VR. Oh my god, that's so meta.
Seeing exactly what your 3D 180 camera is capturing in real time directly inside the VR headset with no latency change everything. You can fine-tune everything on the spot, camera placement, talent position, and stereo depth, while making sure your 3D shot is comfortable to watch in VR. No more waiting until post-production to fix issue. You get instant stereoscopic feedback, making camera blocking easier and ensuring everything looks great in the headset. If the director wants to try a tricky camera move, you can show them right away if it will work or cause discomfort. It keeps things smooth, saving time and keeping everyone on the same page. In this camera to headset masterclass, I will teach you exactly how to set up real-time VR preview for multiple Masterclass headsets with minimum delay. We will cover the Canon camera settings to STMap Generation and even a free OBS livestream workflow. You will learn to avoid common mistakes, communicate better with your crew, and create immersive, comfortable 3D experience without the headache of expensive 3D post-production fixes. This is a longer video, so feel free to jump to the chapter that interests you the most. The on-screen timecode right here will guide you as you navigate through each section. Now, let's dive into the camera choice and how to set them all up for the best results. For our 8K 60-frame stereoscopic 180 video content, we primarily use the Canon EOS R5C, the new Canon R5 Mark II, and the RED V-Raptor X, all equipped with the Canon RF 5.2mm f2.8 dual fisheye lens. This setup ensures the highest image quality when viewing in the Masterclass headset. However, the workflow we cover here will apply to any VR 180 cameras with a 4K 12G SDI or HDMI output. For more detail on choosing the right camera for VR 180, check out our latest camera comparison on Masterclass TV right here. The required equipment. In addition to the camera, standard accessory, and rigging, you will need a desktop or laptop with an NVIDIA GPU. To capture the camera's HDMI output, you will need a 4K HDMI capture card that supports 4K DCI input and output up to 60 frames per second. Devices like the Magewell USB Capture HDMI 4K Plus or the Pro are reliable option, but there are other capture cards out there on the market that will work just as well. To view the live VR camera feed, you will also need either a Masterclass 3 right here or the more affordable option, the Masterclass 3S VR headset. On the software side, you will need DaVinci Resolve, KartaVP, GIMP, OBS, NDI Video, and Central Control Studio Max. While most of these programs are free, Central Control is a paid option. Although it is possible to replace Central Control with just OBS, this introduces additional complexity to the workflow, and that saving might not be worth it. Central Control can achieve a live feed delay of less than 1 second, while an OBS-only workflow typically results in a delay of around 15 seconds. But if you still want the completely free OBS workflow, drop us a comment down below so Kimchi can convince me to make it for you. Camera preparation. Let's begin with the most popular option, the Canon EOS R5C right here paired with the dual fisheye lens. First, ensure your R5C is connected to a stable external power source, such as a dummy battery or a USB-C PT power source like the ZG-Syn Hot Swap Sharp Frame Dual V-Lock battery placed right here. Your battery should be powerful enough to support multiple devices while keeping the camera running. A camera power loss will require resetting the OBS software, wasting valuable time on set. For professional VR filming, using 8K 60-frame Canon RAW LT with C-Log3 cinema gamut. This setup offers the most flexibility in post-production, although it may not provide the best on-set output for the director and the clients. To optimize the viewing experience though, navigate to Menu 5, Page 8, and turn on View Assist, HDMI. set the color profile to either BT709 or CMT709. We suggest CMT709 for its vibrant Canon color, which provide a pleasing look for director on stakeholders without affecting the recorded footage. Still in menu 5, go to page 5 and turn off OSD output HDMI to get a clean dual fisheye feed, which is essential for the STMap workflow later on. Then in menu 9, page 2, under HDMI output, signal, select 1496 by 2160p 4K DCI for the best live preview quality. The camera setting, we recommend setting the aperture to f7.1 for the optimal edge-to-edge sharpness. Avoid going below f4.5 or above f10 to maintain image quality. As for ISO, we typically keep it at 800 and never exceeds ISO 1200. We advise against shooting at ISO 3200 for professional production, as the noise significantly degrading 3D image quality at higher ISOs. For detailed guidance on the best setting for the Canon R5C right here, please refer to our in-depth tutorial right here. Once the camera is set, connect the R5C to your HDMI capture card, such as the Material USB Capture HDMI 4K Plus right here, using a mini HDMI to regular HDMI cable, Canon EOS R5 Mark II. Next, let's move on to the Canon R5 Mark II. Starting by setting the camera to 8K 59.97 FPS in Canon RAW LT for enhanced dynamic range and reduced noise, we recommend using C-Log 2, C2 in the custom picture profile. However, if you prefer C-Log 3, just C3 right here, feel free to use that instead. Now, head to page 8 in the camera menu and ensure HDR C-Log View Assist is enabled for HDMI output. On the last page of the camera menu, set auto power off temperature to high, standby low resolution to off, HDMI display to camera plus external display, and HDMI raw output to off. One of the advantages of the Canon R5 Mark II is it uses a full-size HDMI port, offering a more reliable connection to your capture card. We still recommend using the cable lock to ensure both the HDMI and the power cable to avoid accidental disconnect during filming. Once your setup is complete, connect the Material capture card to your PC and you are ready for the next step. Okay, right now we're gonna talk about how to set up the RED V-Raptor X right here. I'm go figure gonna give you some like real world experience. So this is a live capture, how I set up this camera to go for a live preview right there. It's actually, you already see a camera feed right there. So put the camera in. So first make sure that you go on menu right here for the RED. You wanna go into monitor, set, and we are gonna use SDI1, which is the only SDI that provides 4K signal. Go there, make sure that is at SDI1, and make sure you set the resolution right here to 4K DCI, which will give you the highest resolution output, right? Okay, turn it off. And then right here, make sure everything turn off, like all of this is off, so you not get an interruption of the signal feed into your display right here, which is go to HDMI, but I'll tell you later. So SDI1 is what we need, and SDI1 is this one right here. So see, SDI1 to connect to this special equipment right here is by Blackmagic. It's the micro converter bi-directional, so you get SDI 12G in to HDMI, or you can do HDMI in to 12G SDI. The reason why I get this one instead of the regular one is because I can use this to monitor my RED. But at the same time, when I go to color grading, I can pipe my feed using HDMI in, so right here, and pipe out an SDI out into an HDMI monitor, so you can color grade with it. So I can use these same devices to do VR color grade and also do live camera to VR headset workflow. So it's very convenient. This is like literally say $200 because you don't need to buy two of this, you only need one, you can use it. So from here, we get an SDI, I type it in right here. I get an SDI into, again, my Material right here, SDI in, and then to pipe the feed into 4K DCI 60 frames per second into a Material right here, and then go into my PC right here. And see, you see the signal right there? See? It just go in right here, you see signal. Finally, let's talk about the recommended camera setting for the RED V-Raptor X in 3D 180 filmmaking. We recommend shooting in 8K with the 16:9 aspect ratio instead of 17:9. This allows you to set your R3D to HQ instead of MQ, giving you the highest possible quality, making sure to shoot at 59.94 FPS for smooth playback. The RED V-Raptor X is straightforward to set up and offers excellent stability compared to Canon, making it a reliable choice for 3D 180 production. Networking. To stream a 4K 60 frames per second live camera feed with Molly on multiple Masterclass devices during production, a dedicated network with sufficient bandwidth is essential. We recommend bringing your own networking equipment such as a reliable Wi-Fi 6 Plus or even Wi-Fi 7 router and Ethernet cables to create a dedicated internet network for live feed. If your client are remote, you can even connect the system to the internet and stream the camera feed directly to anyone globally, as long as they have the correct IP address and network configuration. This setup laid the foundation for public VR livestream, similar to the live show you may have seen already on platforms like Meta Horizon Worlds. OBS Studio Part 1. There are multiple ways to stream a high-quality camera feed into a VR headset, including OBS Studio, TouchDesigner, and Assembly Live Effects. However, OBS Studio is the only free solution and surprisingly is relatively easy to set up. Before we begin, ensure you have the free NDI2 software package installed. If not, you can download it from the official website. Before we start the OBS 3D workflow, I do want to point out there is a free OBS stitcher filter called ProSend that allows very straightforward fisheye dewarp and monoscopic preview. If you are not using the Canon 3D dual fisheye lens right here, we recommend the ProSend workflow. I have a separate tutorial right here. To achieve the result we are aiming for, you will need a special version of OBS Studio that supports a 32-bit STMap file. Fortunately, we have made this process easy by providing download link to all the necessary files. Simply follow the link below to download our custom edition of OBS Studio along with a UV map shader file. A word of caution: do not update OBS Studio once you have installed this version. It is a specialized build for VR live preview, and updating will break the setup. If you accidentally update, just go ahead and delete your version of OBS and reinstall our custom version. After downloading and unzipping OBS, create a new folder on your desktop called Live Preview. Move the unzipped OBS Studio folder into this Live Preview folder. Then navigate to OBS Studio, bin 64-bit, and double-click OBS 64.exe to launch OBS. Your new OBS should look like this. First, go to Tool and ensure you have the NDI plugin.manual.out.put settings right here as an option. If you don't see this, make sure you install the free NDI tool package first. Next, click on Studio Mode and ensure Dual Screen Mode. Then go to Profile, New. This profile is your camera video feed, so name it 4096 by 2160 Canon HDMI in. We suggest using this naming convention so you know the exact resolution and camera source coming into OBS. Hit OK, we will cancel the next part. Go to Settings, Stream, set the service to Custom. Now go to Output and set the output mode to Advanced. Under Video Encoder, choose NVIDIA NVENC HEVC to have hardware accelerated encoding. Rate control to CBR and change the bitrate to 35,000 kbps. Preset use P4 medium quality and change pass mode to single pass. Hit Apply. Next, go to Video and set the base camera resolution to the exact input resolution from the camera for Canon, which is 4096 by 2160 4K DCI. Copy and paste the same resolution on output resolution. The FPS value should be 59.97 FPS. Hit Apply and then OK. Now go to Scene, click the plus icon and add a new scene. Name it Canon HDMI Source In. Click the plus icon on the source and select Video Capture Device. Create New and OK. Under Device, select USB Capture HDMI 4K Plus. You should see a clean fisheye source. If you don't see your source, please go back to the camera preparation part of this guide and make sure you follow everything correctly. Under Resolution, FPS type, pick Custom. Resolution, pick 4096 by 2160 4K DCI. FPS, you can leave it to match or select 59.94 FPS. If you have on-set sound engineer who can route in the talent microphone mix, this is where you can provide a dedicated clean audio feed to your director, or you can just use the camera audio. Hit OK, transition it over, you should see this. Right-click on the source, transform, reset transform, and then make sure it is center to the screen by selecting center to screen. Transition to the right windows. Now go back to the setting, go to Output, Recording tab, hit the browser window right here and point it to the live preview folder on the desktop. Recording format to MP4, hit Apply and OK again. And then we can start recording for 5 seconds of a scene. Ideally, you should record a well-lit actual set with a stand-in talent for an easy calibration for the next step. Alternatively, you can do this part in the prep day with a focal chart in 6 feet away from the camera as calibration point. Okay, now we can head over to DaVinci Resolve and generate a template for OBS. STMap Generation in DaVinci Resolve Fusion. Now, let's talk about STMap. An STMap is a 32-bit image that map how pixel should be transformed or distorted. Tools like TouchDesigner, Light Effects, or OBS Studio require an STMap to convert the dual fisheye list from the camera into VR180 format that can be playback live on devices under Masterclass. The STMap we are generating here can also be reused in post-production as a director-approved 3D depth template, streamline the whole workflow from onset to final delivery and reduce post-production costs. You can generate STMap using two primary software, Mythical VR and Blackmagic DaVinci Resolve Studio. You can also use the free version of DaVinci Resolve, though the input resolution is limited to 3840 by 2160 4K UHD, which may result in lower quality live previews. But if you're okay with that, go with the free version. Since DaVinci Resolve Studio is the most popular option, we will focus on generating the STMap using that software. We already have an in-depth series on STMap generation on the Canon EOS VR system, available on YouTube right here. You can refer to that link for additional detail. However, we will walk you through the process step by step here as well for those new to the workflow. First, download the Reactor Package Manager and the open source KartaVP tool from Andrew Hazelton to enable the STMap workflow. Download the Reactor Installer.lua script file right here, link in the description. Next, start a new section in DaVinci Resolve and navigate to the Fusion page. Drag the installer script from your desktop into the node view and run it. When the Reactor installer dialog appears, you can proceed with the default setting by simply clicking Install and Launch. Once Reactor is installed, navigate to Kartaverse and select KartaVP. I recommend selecting all components of KartaVP and hitting Install. You will be asked for permission to install various dependencies throughout the whole process. Just click OK as needed. The plugin and dependency are free with love. After the installation is complete, we start DaVinci Resolve and you are ready to proceed with the STMap workflow. Now let's move on to generating the STMap. Begin by dragging the OBS output video into the media page. Right-click on the media page and select New Fusion Composition. Ensure the frame rate is set to 59.94 FPS or match your OBS capture frame rate, and rename it to STMap Generation Comp. Double-click to enter the Fusion Comp. Open the media pool if not already open, and drag the OBS capture footage into the comp. This will automatically create a media in node. With the media in selected, press Shift plus spacebar to open the search bar, then search for KVR Fisheye Stereo and hit Add. This is a special node we have built for STMap generation across various camera systems. While it may seem complex, we have provided template for common setup like the Canon R5 Mark II right here, the Canon R5C, RED V-Raptor, and even Canon R7. Download the JSON template folder from the link provided in the description down below and unzip them. Click Import JSON and select Canon R5C input 4096 by 2160 output 4096 by 2160 HDMI. To preview the footage, assign window 1 to media 1 by pressing 1 on your keyboard and window number 2 to KVR Fisheye Stereo by pressing 2 right here. You should now see a defish RGB result. If not, select RGB in the view mode drop-down. The preset will give you 90% there, but we will fine-tune it together. Let's refine the 3D alignment by enable Anagraph. Switch to single window view and fit the preview to the screen. Right-click and enable Show Guides and turn on KVR Guides-SBS. Hide any other guides you don't need. The KVR guide comes free with your installation of KartaVP. With the guides enabled, focus on removing vertical disparity and optimize horizontal disparity. Start by resetting the global align X shift and global align Y shift. Adjust the X shift to remove horizontal disparity at the optical center, and then adjust the Y shift to eliminate vertical disparity at the optical center as well. This ensures that the object in the center of your frame has 0 3D depth, which serves as a solid starting point for 3D calibration. In VR, your zero parallax point should always be set to infinite. A good practice is to set the 0 3D depth point to the furthest object in your scene. Now that the vertical disparity has been removed, you can adjust the X shift again to remove most of the horizontal disparity on the background elements, such as the wall or the windows right here, which are the furthest object in this scene. With this process, you now have a well-calibrated 3D shot. The main object in the center has good 3D depth and there's no parallax on the furthest object, ensuring an optimal viewing experience in VR headset. Turn off Anagraph and make sure your com size is still 1496 by 2160. If not, adjust the size by adding and subtracting small value to get back to 1496 by 2160. You can type in the plus or minus operator here to get the precise adjustment. The reason the STMap dimension can differ from the final com size is that we use this number to crop down to the final com size. This can be confusing, but in general, you should not need to adjust this value at all if you use our template. We continuously optimize the STMap generation workflow, so check back regularly for updates as DaVinci Resolve evolves. We did a lot of hard work to make this workflow as easy as possible, so don't forget to give Kimchi a thumb up. If you want to understand how to generate an STMap from scratch though, you can refer to this tutorial right here. Ideally, the only adjustment you will need to make are the global align X shift and Y shift, unless your camera or lens is miscalibrated, which is rarely happen for Canon optical precise lens. When you are satisfied with the calibration, switch to STMap view mode, right-click on the STMap, select Save Image, and save it as a 32-bit EXR file. Be sure to add .exr to the end of the file name. Use a consistent naming convention that includes the camera name, lens type, and input-output resolution, so it's easier for others, like your first AC or DIT, to identify and use the STMap template correctly. Once you have generated STMaps for all your cameras, you can transfer the files back to your PC and continue with the final steps. TouchDesigner. If you have a TouchDesigner license, the next steps are pretty simple. One advantage of TouchDesigner is that it can also run on a Mac. However, it does come with the downside. The commercial license costs around $600 while OBS is free. To get started, open TouchDesigner and delete all the nodes. Press Tab or right-click to select Add Operator. Add a video device in node. You should see your webcam feed pop up now. Go to the Input Device dropdown and select USB Capture HDMI 4K+. Now, you immediately see your RED V-Raptor X camera feed in 4K TCI resolution. Next, hit Tab again and add a movie file in node. Select the STMap EXR file we generated earlier. Then add a remap node and connect the 4K video feed to it, along with the STMap. Now, you will see your raw fisheye footage transform into a VR180 signal. Finally, add an NDI out node, search for NDI and edit. Now, you are streaming your RED camera feed live. Open NDI video and studio monitor, and you should see TouchDesigner as an available source. You will see the live camera feed, and this can be picked up by your Masterclass VR headset over the network. From here, you can resize, reposition, and adjust to meet the final output spec. TouchDesigner can also be used for doing projection and other edge application. Drop us a comment below if you like more TouchDesigner tutorial for immersive applications. OBS Studio Part 2. Before using the STMap inside OBS, we must convert the EXR file into a TIFF file. Well, you can use Adobe Photoshop for this if you use a free open source alternative, GIMP. To save on cost, of course, because Kimchi loves to save you money. After downloading and installing GIMP, drop in the STMap EXR file, go to File, Export As, select File Type by extension, and choose TIFF, image from the dropdown, hit Export, convert the default setting, and export the TIFF version of the STMap. Now, go back to OBS. In Scenes, click the plus icon to create a new scene, naming it Live Preview. Next, go to Profile and create a new profile for streaming. Name it 4096 by 2048 Live Preview. The 2:1 ratio is the standard for VR180 video delivery. Hit OK, then cancel on the next section. To better understand what is going on here, the first scene, the Canon HDMI source in, capture the camera feed in the native resolution. The new scene, Live Preview, is what we will stream into MetaQuest. Now that we are in the new profile, go to Setting. In video, set both the base canvas resolution and output resolution to 4096 by 2048 with an FPS of 59.97. Hit Apply and OK. In the Live Preview scene, go to Source, click the plus icon, and add the camera HDMI source in. Right-click the source, select Filters, click plus, and choose User Defined Shader. Check Load Shader Text from File, then browse and select the UVMap.shader file provided in the download package. Under Remap Texture, browse to the location of your generated STMap TIFF file from DaVinci Resolve and GIMP and open it. You should now see a DaVinci final output, similar to what you view in RGB mode in Resolve. The difference is that this is a live camera feed. Since the input source is larger than 2:1 ratio, you may need to adjust the footage. Go back to Canon HDMI source in and move the source vertically to level your footage. This effectively reframes the VR180 feed. Now, select the Live Preview scene and hit Translation to move it over to the streaming window. Go to Tool, NDI Plugin, check NDI Output, and name it OBS Live. Hit OK, and you are now streaming NDI Live. Woo! If you open NDI Video 2 now, and then Studio Monitor, you go to Source, you should see an OBS Live as a selectable feed. This NDI feed can be picked up wirelessly anywhere within your network, from NDI to MetaQuest. MetaQuest doesn't natively support NDI video, so we will set up a local video server to stream using WebSocket. You will need Central Control Studio Max for this. There is a free way to do it with only OBS. Kimchi did tell me that he want me to make a tutorial next to teach you how to do this part for free, but for production, it's worth investing in a software that is more reliable. After installing Central Control, open the software, hit Add Device, search for NDI, and select Central Control Connect NDI. Double-click it, then under NDI Source, choose OBS Live. Set the resolution to Custom and the frame rate to 59.97 FPS. Select NVIDIA RTX as the encoding device. If custom resolution isn't available initially, click Connect, go to Settings, and add 4096 by 2048 as a resolution. You can also change the port number, but we will leave it as the default 8066. Turn on NDI and the stream will begin. Next, click Connect, get the link, and look at the IP address dropdown. If you have multiple IP addresses, test them to find the one that is streaming into MetaQuest. For most setup, only one IP will be displayed. Copy the link and send it to a service like Google Keeps so you don't have to manually type that whole long URL in your MetaQuest browser. Now, put on your MetaQuest 3 or Quest 3S, open the browser app, and paste the link from Google Keep in the address bar. Bookmark it for easy access in the future. In the drop-down menu, select NDI source. You should now see a side-by-side live video feed from your Canon camera. Double-click the video or choose full screen right here. In the menu dropdown, select projection and choose VR180 side by side. You will now see the correct 3D 180 video feed with minimum delay. Thank you, WebXR!
Whoa. Live. Yoda right here. Yoda next to me. I'm live, watching myself live in VR. Oh my god, that's so meta. So meta. The camera, looking myself live in VR. Oh my god. And in 3D. So meta.
This setup delivers the highest quality and fastest near zero delay stream, providing the best on-set preview experience for director, clients, and stakeholders. Thank you for watching this very in-depth tutorial on how to stream your VR camera to a VR headset. If you are working with a cinema camera like the RED V-Raptor X right here, we will dive into RED Connect for 8K immersive 1D live streaming at the highest professional level. If you are interested in 360 or mono 180 camera to headset workflow, check out this tutorial right here. Don't forget to subscribe and hit the notification bell so you don't miss out on advanced immersive filmmaking masterclass just like this one. If you have any question, and I'm sure you will, feel free to drop them in the comment section down below, and Kimchi and I will do our best to help you troubleshoot and get your stream up and running. Thank you again, and we will see you in the next tutorial.